So, are we currently overhyping AI, or is there actually a new layer being added to it?
I think the new layer is added, but also it's worth recognizing that everything we do in our life is already AI. If you think indeed of Google back in whenever it started, 97, it was AI. That was their PhD. Sergey and Larry's PhD was literally in AI. It just back then, page algorithm was and like the amount of AI, for example, that happens in your feeds in TikTok and Facebook and Instagram is insane, right? It's all optimized to effectively, get you to spend more time on the platform. I think what changed with transforming models and scaling them is the so-called semantic understanding. Like most of the AI before, or machine learning, has been effectively on behavioral features, right? You watched three movies that I watched. Let's recommend you the fourth movie I watched. It doesn't matter what movies are those, like just to give you an example. You scroll through TikTok, through this video fast, through this video slow. Well, there's 100 other people who did kind of similar thing. Let me cluster you into that group and show you similar videos that group actually spent more time on. What generative AI brings, and kind of generative is probably the wrong word, semantic AI in reality, is really understanding of the content and the meaning of be that video or text or image. And using that now is way more intelligent, right? And you can do a lot more things with it. Now, I think reasoning added even next layer where you kind of feel like there's this large discussion that like this model is a statistical parrot. They just learn the distribution and then you tell them to like, okay, it only can answer you the things it have seen, right? And I would say like there is some truth to that because that is how these models work. It cannot like purely on itself, it cannot come up with something completely new. But you can use so-called like search algorithms, right, where you're effectively unrolling this model out of distribution and then it's able to find new things. Now, what this reasoning models and effectively how they trained is effective that is like you're starting to sample and finding new ways how you combine existing concepts. And that is how humans work, right? When we're coming up with new things, it's not like we start from clean slate. If I'm writing a new novel, taking existing things and combining them in novel ways. And so reasoning in many ways bringing that as well. And there's like newer ways to do reasoning with searches and other things, Monte Carlo search, etc. So point is like I think we are at the next wave and kind of I would say there's actually been two-step functions that happened. One is the GPT moment so-called, right, where we've seen like, hey, the LLMs can actually semantically understand meaning of concepts just from effectively throwing a ton of training data at them. And then the second happened with O1 and DeepSeek R1. And it's like, hey, there's actually, if you train it in this new way, and it's possible now because it understands semantics, it is now able to search in kind of broader space, even if it hasn't seen exactly this combination. And that is really close to how we learn, right? We learn, go to school, we learn all the stuff that been before us, and then, if you go do PhD or you do art or you do something creative, it is all combination of all the prior knowledge. And so I think like we're getting really close to systems that are able to, and we've seen already, right, prove new mathematical things that come up with new eventual hypothesis for physics, etc.
I mean, you're stupid if you're not using AI within any company that you run. Like I've got multiple entities that we run at the office here. We are starting to use way and way more of AI. But I've also been listening to a podcast recently, and I've been dying to just ask you some questions on this. It was with Roman Jampolsky. I don't know if you have heard of him before. He is an
Yeah.
AI safety expert. Um, and he basically says that if we go on by adding more inputs into AI, we create super intelligence. and then we either die or we have a beautiful world. So then we get past the point that the AI is learning like a human is learning because they start to learn by themselves, and then they can tweak around, and can't just keep up with the AI anymore. What's your view on that statement?
Yeah, we call it nirvana or near. Um, yeah, I mean, this is a very large topic, right? And so the way I usually approach it is by decomposing it into a number of smaller topics and addressing them and kind of building it up, right?
Mm.
But I do think AI is, I call it the last technology wave. Right? We've had, Gutenberg press, we have industrialization and steam, we had electricity, we had cars, we had internet. And like every one of these effectively dramatically changed how society is organized, how we do productivity, like, GDP is effectively conditioned on that technology. And so I think AI will be that next wave, but it's also going to be the last because everything after it will be done by AI directly. You don't actually need, like, I think the people like, oh, we're going to do X job, right? And it's like, well, AI can do X job as well. Like that's the whole point of intelligence. So I do think like over time that's going to happen. We are we are in an interesting, time for sure to live because we are going through this transition, and transitions are always interesting to say the least. Now, what are the things that we want to ensure doesn't happen? Well, first and foremost, right, if we imagine be that ASI or just, and I think like there's a little bit of like different things. I think individually, we actually don't want ASI. We want just kind of extension of ourselves. We want us to be smarter and more productive and have an army of actually like assistants that are working on our behalf, but they don't have like their own kind of will. Uh, and then indeed there can be a technically a new species, right? That is like a digital side that we need to make sure is. And so in either case, what we don't want is that there's a single company that is controlling that. And similarly, how you wouldn't want electricity to be controlled by a single company. Internet, if you remember AOL time, where effectively internet was AOL in America. And if you want a website, you need to list it as AOL. If you want to access, you need to get AOL access. And so like AOL was the definition of this. And I think like even in a short to medium term, as we individually becoming more kind of using AI to see the world, like to interact with computing. To give you an example, right now we're already doing that through Google, Instagram, Facebook, TikTok, right? AI is effectively defining what we see, how we see in the newsfeed, etc. This AI is not on our side. It's actually trying to make money for those companies, right? That is its goal. And so you really don't want to live in a future where more and more of our kind of content is produced by AI that's trying to make money for someone. So this is where what we call user on AI comes in. Is like, how do we ensure that we individually actually have our own AI that belongs to us? And it's kind of on our side, it's equally distributed, equally accessible. Obviously, there's a number of additional safety questions coming from there, but that's kind of piece number one. And a lot of what Near been building for the past year is really to address this challenge. How do we have decentralized, user-owned AI? What does that actually mean? How do we build it? How do we serve it? How people can access it? Now, if we look a little bit further, okay, well, the AI capabilities are indeed growing. I think the approach of like alignment, where you effectively trying to do brain surgery to make sure the model is behaving how you want it to behave, right? I think it's kind of a losing battle. Yeah, no, we're gonna beat you up if you like. It's like you put a model in front of a therapist and you like tells therapist to find all the issues with that person, right? Like you never know what dark things are happening in somebody's head. And so the alternative to that actually is a combination of techniques that we're working on as well, One of them is kind of this core idea that we want to make sure, because AI should be user-owned, it should be private, there should be a way to verify that the outcome I'm getting is from, this model, this system, AI system. And so what we use right now kind of to ensure this is so-called trusted execution environments. So it guarantees you both confidentiality and verifiability. I know this specific model was run, it was run on my data, nothing else was touching my data, nothing else happened with it. And so that gives you an interesting guarantee because now you know what you're running. Like right now, there's this kind of on Reddit, people complain that, Claude is like becomes dumber between this hours, etc. Like people don't actually know what they're running, right? It can be different model, things can change under the hood, etc. You have no idea. So we actually ensuring that. So that already gives you some guarantees because like now you know what's happening. Now the model still can misbehave, and especially as we give it tools, as we give it more instruments to go and do things in the real world, it can go and do things that are against, what we want. So this is where the mathematics helps. So one of the kind of this concepts in smart contracts actually is called formal verification. This is where you verify that the smart contract does exactly, like mathematically exactly what is expected. Now, one of the challenges with that is historically has been a very kind of laborious process. You need like effectively mathematicians to sit there and like prove every line of code and kind of formalize it. And it's also the errors can occur kind of across multiple levels. And so with AI, we can actually do the proving itself a lot more effectively. That's number one. But number two, you want to do this not just on smart contracts, you want to do this on AI systems. And so to give you an example, you can effectively say, like, as I'm calling into the AI system, let's say I want to, book myself tickets to Lisbon. I add the conditions. I don't want, I want end up with a ticket to Lisbon, and I don't want anything else, any other outcomes that are um, not within my expectations. And so the system needs to prove to me that that will happen before I, for example, give it my money. So what this gives you is effectively a way to verify that the whole system, whatever tools it will use, will actually, be serving my request with the specific conditions. It doesn't matter how, right? Like I'm not trying to do brain surgery. I'm putting the guardrails around it and kind of how it's doing it. And so that is to me one of the really important parts that we need. It really combines, kind of builds on top of what we're building, which is kind of verifiable, because you need the container to prove it, right? Like otherwise, the model can change itself and and go do something else. But you want a container. That container proves to you that like, hey, whatever's running inside is, will follow the rules, and container ensures that it doesn't go and escape and does different things.